Okay, we're getting to one of my favorite subjects in statistics now, which is regression. So we're going to be doing what we call simple linear regression, which is when we are just looking at a relationship between an x and a y variable. And we are going to limit our relationship to linear relationships right now. And of course, you probably know that two variables can be related in a lot of different ways. It could be exponential or they could be quadratic, but we're going to only discuss linear relationships in this section. So let's talk about what regression is. So regression analysis, it takes data that kind of looks like this big scatter of stuff, and it says, okay, I want to kind of fit a line. I can see a trend going upwards, and I'm going to fit a line in here somewhere. So I think there's a trend line that goes there. And what it ends up looking like is you have x is the independent, which is also called the predictor variable. So x is your predictor, and y is your response variable. And what we normally do is it has the form y equals ax plus b. So we create this line and we fit this line. Here's this guy trying to fit this line here, where does it go exactly, with a bunch of data. And we fit this line the best we can with the data that we're given. And in this time, it's really weird. Now, before you probably saw y equals mx plus b, where b was actually the y-intercept. But in statistics, b is actually the slope of our line, and a is our y-intercept. So that if we did continue this line all the way to the end right here, that's where it would start. That would be the y-intercept. So this would be our a, and then our slope, which would be rise over run, would be b. So a little bit different notation than what you're used to. So we'll talk about how to look at that and how to analyze that. And just a little history in case you're wondering, it's actually called regression because the original studies were on sons. And what would happen is really tall men would tend to have sons that were shorter than them. So it would go toward the mean. So it would be regression toward the mean. So they would kind of like regress over generations. And really short men will have sons taller than them because they'll go toward the mean. So everybody's kind of regressing toward the mean in some way. Just kind of analysis that started the term regression, and that just kind of stuck. All right, so again, in math, it's y equals mx plus b. But in statistics, we have y equals, it's either this, sometimes we use this beta naught and beta 1. And this is the precursor to multivariate statistics, because, I'm going to run out of letters if I use this. We'll use beta naught, beta 1, beta 2, beta 3, beta 4. We can have like all kinds of variables in there. But when we do just simple linear regression, we're going to use a plus bx, and the test in your calculator use this notation. So your calculator does have the opposite notation, and it's listed first in your stat calc menu. I'm going to show you this real quick. If you bring up your calculator, you can see, let me get out of this. You can see if you go to stat calc, number 4 says lin reg, but notice it says a plus bx. This says a plus bx. This is not the one we want. We want the other one. So if we go down here, I'll show you what happens. Look at all these different regressions: quadratic regression, cubic regression, quartic regression. But number 8 is the linear regression a plus bx. This is the one we use. So number 8 is the one we use if we're going to do that. Now, Normally, and actually, I use the test anyway. Okay, so that went away. So technically it goes by this, and then this is number 8, and then this one's the one we don't want, is number 4. So A is our intercept and B is our slope. Really important, because if you get them mixed up, that's kind of a problem. All right, so what I've actually done here, and this is actually quite interesting, is I've taken some ALEC scores and a first test score on a course that I'm teaching. I'm not sure that if it's stat or math. I don't actually remember which one I used. But if you have this ALEC score and your first test score is the same, then it may be a year in here. I don't remember. So the first step that we want to do anytime we're given 2 bivariate data, so 2 variables, an ALEC score and the first test score. And we're going to see if I can use the ALEC score to predict how somebody's going to do on the first test. So remember, the ALEC score is those of you who did take the placement test to come in to get into this class. So the first step is always to create a scatter plot of our XY data. So that's what I've done right here. I've created a scatter plot. And what we're trying to do is we're trying to look at this and say, well, does this look like a trend? Does it look like it's going up? Kind of. This is real data, remember, so it's not going to be perfect. So what I do in order to make this is I try to find the line that makes the sum of squares of the distance between the line. So let me show you what I'm talking about here. So if I take the distance, say from this point to the line that I made, and this distance, and this distance, and this distance, and this distance, etc., and then I'm going to square this number. So I'm going to take this distance, and I'm going to square it. Take this and 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 square it, etc., etc. This one. And so what I'm going to do is I'm going to minimize what we call the squared errors. And that's what they call it, least squares regression, because we actually minimize the squared errors in order to make this regression line. It's really kind of neat. So now, that's the best one that we can get. That's the one that makes the errors squared the smallest. And we can go on. Okay, come on, computer. All right, so here is how we go about doing this by hand, which is rather ugly. So this is what our B is. Not that you cannot do it. It's just not the easiest thing in the world. You'll notice that you have to find the mean of the X's. You have to find the mean of the Y's. Okay, then you have to find the distance between each value and its mean. Oops, it didn't like me, did it? Okay, it came back. So we find our B in this way. Now, there are some shortcuts that you can actually do for this to make this a little bit easier using 2var stats. However, we're going to use the calculator anyway. We can do linreg t-test, which is my favorite one to find A and B, because it also includes information that we're also going to need next time. And then, of course, your A, you can actually find out just by taking the mean of the Y's minus B times the mean of the X's. So that finding the A, once you have the slope, is fairly easy. So we're guessing that our line is in here somewhere. So let's talk about the procedure that we're actually going to use for this. So our procedure. Step 1. Enter the data into list Whoa. Okay, this thing doesn't like me today. Enter the data into list 1 and list 2. So what I'm going to do is I'm going to go up here and I'm going to get my data first. So here's my data. And move it over so you guys can see it. Okay. I'm going to enter my data, and so I'm going to go stat. Oops, I'm already at stat. Edit. I'm going to clear some lists here. Okay, I'm going to enter my data, 93. I'm not going to sit here and bore you with this. Magic. Voila! I now have the data into list 1 and list 2. So now if you want to go ahead and do that, you can hit pause now and go ahead and put that in there. Okay, so we are going to move this up. Oops. So this is our first step, just like I said. Enter our data. Our X, or predictor variable, usually goes in the first list, which is what I've done. So this is the Alex scores in the first list. Our Y, or response variable, also called our dependent variable, goes in our second list right here. So the next thing I'm going to do, remember the first thing I do is a scatter plot. So this is how we go about doing a scatter plot with these calculators. And those of you who have a little different calculator, you're going to have to see me. I'm going to try to see if I can find information about how to do scatter plots with, I believe I have, so we have some TI-89s, we have the Inspire CE, and I know I have a couple people with Casio, so I will try to see if I can find videos for those as well to put into Blackboard for you. So the first thing I do is I go second y equals. So I go back to my stat plots. Second y equals. So I'm going to turn my first stat plot on. So hit enter, turn it on. And then using my side arrow keys, go to the first graph type. This is the scatter plot. So this is the first type. I don't have to really use the side arrow keys. It's already there. And I'm going to do list 1 and list 2. Mark, it doesn't matter. I'll just make squares. It's easy to see. And I'm going to hit zoom 9 at the bottom. So what that's going to do is I don't even have to hit graph. I can just go zoom 9. And there it is. So there's my scatter plot. So for this class, all I'm going to expect you guys to do is to go ahead and just give me an idea of what your scatter plot looks like. It does not have to be perfect. What I'm doing is just fine here. There's one here. There's like a little set of 3 up here. There's one like here and one like here. And then there's a couple here. So that's kind of what my scatter plot looks like. So that's the first thing that I would do. Now, I'm going to go to my, like I said, I like doing the t-test. We're going to be doing the t-test next time anyway. It's just, this just does everything at one time. So I'm going to quit out of this, second, quit. And I'm going to go to stat, tests, linreg t-test. And it's down here. I guess I should have went the other way. There it is. And this one has an interval. Not all of them do. linreg t-test. I'm going to hit enter. It just comes up. The X list. That's my predictor variable, list 1. Y list is list 2. Frequency is 1. Now, for this where it says beta, or this is actually the Greek letter rho, in case you're interested. Beta and rho, we're actually just going to use a not equal to for the test. So that's just not equal to 0. Don't worry about that for now. We'll talk more about that in the next video. So I've already got everything here. Now under reg EQ, I want to tell this to store my regression equation into Y1. What that allows me to do is that's going to allow me to graph the regression equation on top of my scatter plot quite easily. So to get this Y1 into this location, we hit vars, yvars, and then I just want function, Y1 enter, and it gets Y1 there. Now I'm going to calculate. All right, so here's the output. LinReg t-test output. Y equals A. At the very top it says Y equals BX. This reminds you where A and B go. This reminds you that A is the intercept and B is the slope. So we're going to scroll down until we see A and B, which is just one more. So we can write down a regression line. So we got an A of 40.0. I would go at least 3 decimal places on these. The problem with regression lines is if you don't, you tend to have problems. So our regression line is Y, and I like to say Y hat actually, because this is just an estimate. Remember, things that have hats on them are estimates. Y hat equals 40.068 plus 0.591x. And I have my regression line. So now what am I going to do with it? So I actually went to 4 decimal places on this one. So we got our regression line. Excuse me. Now, like I said, I said 4 or 5 here. So keep our regression decimal places to 4 or 5 to ensure they're more accurate when I use them for predictions. And this hat on the Y indicates that this is an estimate. Remember I said estimate of the possible mean Y value. So now, since we entered Y1 in the regression equation, we can hit zoom 9 again. Okay, watch this. Just hit it again. Hit zoom 9 and watch this. Ta-da! We get our regression equation. We actually get the line that we need. So I could actually go back here. I'm going to use a different color. Go back to blue, I suppose. And looks like something like that. So what we have, I guess I didn't do that quite that well. Okay, so then we can see exactly where our regression line is. And I've drawn another picture of that over here too. Okay. So now let's see what we can do with this regression line. So now that we have it, we can make predictions about scores we might expect on test 1 from students who got certain scores on the ALEKS test. So this is actually something that several of us in the office here have already done. We're looking at how this, because those of you who haven't been here or who have been here quite a while know that this ALEKS test is fairly a new way of taking a placement test, and we're kind of still evaluating it to see if it gives a good predictor of how students are going to do in class. We don't want to put you in a class that you're not ready for, because then you may not do well. And, we don't want you to have to retake something that you already pretty much know everything in either. So this kind of tells us how accurate is our ALEKS test for predicting how well a student's going to do in class. So usually it's that first test score that you kind of know. So looking at this also helps us set the boundaries for the ALEKS test. So we know our Y hat is equal to this. What is the expected first test score of a student who got a 75 on the ALEKS test? And the way we do that is just plug that in for X right here. Okay? And there's some shortcuts actually on the calculator that you can use. I'll show you that real quick. You can call up Y1. Remember, Y1 is this equation right here. And remember, you can do that by going vars, Y vars, enter, enter. And then in parentheses, put the number you want, 75. So 75, enter. And look at that, 84.43. So that is the average school. Uh-oh, typo. This is the average score that students who score. Okay, so the average score of students who scored 75 might get on the first test. Oh, it is Stat 252, so it is your class. So that's what this is. So if you scored a 75 on the test, the average score for all students that score a 75 on the ALEX test before taking Stat 252 will get about an 84% on the first test. Okay, not too bad, right? So remember, that is an average. So let's talk a little about interpreting what this means. So we have a regression line. How would we interpret the meaning of A and B of this line? So A is our y-intercept. This might mean this would be, well, doesn't mean much. It doesn't really mean the score that somebody would get if they got a 0. And the reason that would be is because we would have to extrapolate this line all the way out to say a person got a 0 on the test. So if they got a 0 on the placement test, yeah, they're probably not in the class. And they probably got a 0 on test 1 too. They're certainly not going to get a 40 on the first test, or they might actually if they got a 0 on the ALEX test. But since that's outside of the scope of the data, we don't really say that. So theoretically, it's when x equals 0, okay? But many times, but this only works if the data goes that low. So if the x coordinates that you have don't go to 0, like this one doesn't even get close, it would be way over here, then you can't just say what someone would get if they got an ALEX score of 0, because you really just don't know. So B is our slope. Now this does have a bigger meaning. This means that for every 1 point increase, so if we go over 1, for every 1 point increase on the ALEX test, the average first exam score increases by 0.5915 points. So what would happen with 10? 10 would go up 5.9 points. So if you scored 10 points higher on ALEX, that would take you 5.9 points higher on the first exam, on average. So I want to make sure that word average is in there, because remember, this is just looking at the average. So this is how we interpret slope for a line. So in general, we might